All right, on to part two. So for this one, the graph is given, and this is the first question in the show all work. They get, section by section, they get increasingly more challenging, or at least more intricate in terms of what you have to do. So this is saying, state an interval where or when Sally is traveling at a constant speed. All right, constant means not changing. So for this part, it's increasing the speed. All right, same deal here. Then over here, it's decreasing and getting slower and slower. It's only at this plateau here that we have a constant speed, all right, depending on the passage of time. So she's going 35 miles per hour from, what is that, 5 to 9. So we could say when time, so who knows what the units are, we could say it a few different ways. One would be 5 comma 9 with square brackets. Or we could say 5 is less than or equal to t for time. I'll make a little note here that that's what I'm calling the units, which is in turn less than or equal to 9. Or you could write it in words. They allow for that. All right, so you'd say from the 5-minute mark to the 9-minute mark. All right, so those would all be acceptable generally. So let me write or from minute 9. Minute 5 to minute 9. All right, so it was, like I said, a couple different ways that you could do it, or at least write it. As for the explanation, I have to say something to justify why I made that selection. All right, and in the case of a constant speed is a speed that doesn't change. All right, and that's graphically, that's horizontal. All right, so a constant speed is a speed that doesn't change. It's a horizontal segment in the graph. The only place that happens is between 5 minutes and 9 minutes. Or words to that effect. They allow you to state it in a way that makes sense to you, as long as it's clear what you mean. All right, and correct also, but one thing at a time. Graphing a parabola. That's pretty much all calculator work. So I'm going to do, f of x equals x squared plus 4x plus 3. All right, so I can grab some points right off of this if I want. I got the turning point there. I got all these nice points that I could work with. So I'll show you the table in a second, but it looks like we got a lot of good stuff right here. All right, so the parabola is going to go upward this way. It's got to be symmetrical around the turning point. So it's also going to go up here, but then I'm like, oh, I don't have a point. But if it's symmetrical, then I could just count boxes over and come up with this point here based off of this one. All right, because they're not asking me to graph this, but I'll show you real quick if I could find it. There it is. This is my axis of symmetry. So whatever is on the left side of it has to match with whatever's on the right side of it. But like I said, they didn't ask us to graph the axis of symmetry, so I'm going to pull that out. Oh, but they do ask us what is the axis of symmetry, or state the equation of the axis of symmetry. That's a vertical line, so x equals, and it's at -2. So let me get rid of this now. Make a little table of values here, just in case when I come back to it and check in my work, I'm like pretty confident that I did it right. All right, so we had -4, 3, -3, 0, -2, -1, -1, 0, and then 0, 3 it looks like. Then the middle one here is your vertex, but that x equals -2 is that x value for which the graph turns back upon itself. All right. State an appropriate value for m in the table, so let's highlight it over here, so that it remains a function. All right. So it would need to pass the vertical line test. Let me get rid of this. I can plot all this if I want. Yeah, might as well. Oh, actually, going back to that previous question, if you wanted the table of values, let me just bring this back. If you wanted the table of values, you could hit that little gear and then tap on table. And it gives you a set of points. It's not always the points that you want, so you got to be careful about that. But it usually gives you enough to get started. So here I wanted to go -4. And even if you wanted to go by the domain of the graph, I can go, I'll say -5. Oops. Then -4, -3, -2. I got my -1, so I'll just keep that. Then 0, 1, 2. Like you can go as far as you want. All right, but you get that clear turning point. It goes from 0 to -1 and then back to 0. So you can get your axis of symmetry that way also. All right, so figure it was worth talking about. But in this one, we'll do it by table. So I have 0, 3, 2, 6, 1, 5, 4, m. And 6, 2, 7, 5, 8, 4, 3, 9. All right, it's giving me a hard time with that m. But if I create a slider for it, just by designating m as some number, call it 0, it gives me the ability to kind of play around with it. So that point here at 0, 0, 9, where I have it, I can move my slider. You see it's going to move all along. All right. I just need to pick a value that will not cause it to fail the vertical line test. So if I left it there, I'll just draw, I'll do x equals 0. I'll make it red. All right. So I created a slider for that too. If I slide this along, you see how it intersects 2 points there, but nowhere else. All right, so 0 would be a bad number for that m. All right, but if I moved it over, I can go a decimal if I want. Does it say anything about it being a whole number? It doesn't. But really, as long as it doesn't conflict with any of the other x points that I have on my graph, then it's good. So like, for example, if I put it here, that's going to be a problem. But if I put it here, it's okay. All right, you see how it intersects that one dot, but not the other one. But I don't necessarily want to use a decimal value of 6.3. So I get something cleaner. But I could really go anywhere if I want to put it at -2. They just want you to demonstrate that you understand the vertical line test. Right? So you can't have, if it's going to remain a function, no repeated x values. All right? And I guess that's part of the explanation. All right? To be a function, each x value must only lead to one y value. All right, so for example, if I have 3, let's say 3, 2, and 3, -1, you see how 3 gives me 2 possible y values? If I have an x value of 3, I get a y value of 2, or a y value of -1. That's bad. That's not a function. The other way around is okay. So if I have, let's say 2, 3, and -1, 3, that's totally fine. This would be a function. All right, so you could repeat the y values. You could have repetition in the y's, you just can't have them in the x's. All right, here we have no repeated x values, or at least that's what we're looking for. All right, so I would say m can equal, what do I have it at here? I'll say 8. I just asked for 1. All right, so if it's going to be a function, you can't have any repeated x values, and that's what selecting a value like 8 as opposed to like a 5 or a 1 or a 2 or something like that would do for you. Solve by completing the square. All right, looks like they already got rid of the 33 for us, which is nice. So x squared plus 8x, I leave a little space to complete the square, is equal to 33. Depending on how you learned it, you might have learned it as take the b value, cut it in half, and square it, and add it to both sides. All right, so take the b value, cut it in half, and square it, and add it to both sides. You might think of it that way, in which case you're adding 16. All right, remember it's in the form of ax squared plus bx, and plus c and things like that for a quadratic, but these are the only ones you care about. So when I say the b value, I'm talking about the x term. All right, another, you may have seen it as a rule. If you add b squared over 4a to both sides, that'll get the job done too. All right, either way. So if I had 8 squared it, divide by 4 times 1, because the a value, the leading coefficient, is equal to 1, I get 64 over 4, which is 16. So either way, you're getting a 16. Then you factor. There should be a perfect square trinomial on the left. And on the right, what do we get there? 49, it looks like. So perfect square trinomial, to get the factors, we take the square root of the first term. This might sound familiar, just like, or similar way of saying it as question number 1 in part 1, except that was difference of perfect squares. This is a perfect square trinomial. Take the square root of the last term and carry down the middle sign. All right, now you might say, oh, that's not a middle sign. That's the first sign. There's an understood positive sign in front here. So on the left side of the equation, it would be the middle sign. So that comes down. So we'll get x plus 4, which could be rewritten as x plus 4 as a quantity squared. I want to get rid of that power of 2, so I take the square root of both sides. Left side, x plus 4. Right side, square root of 49 is 7. But because we are the ones taking the square root, it's not a principal square root. It's an active square root. So I have to throw a plus or minus on that. Then I subtract a 4 from both sides. And we typically write this with the plus or minus part at the end. So x is equal to negative 4 plus or minus 7, which breaks up to negative 4 minus 7, negative 4 plus 7. No guarantee it's going to be a rational number. You might end up with a radical that you just can't get rid of, and that's fine. But here I'm looking at negative 11 and 3. Well, really, or is what my x value is going to be. All right. No reason you can't check it on your calculator, but you do have to show the work to get in using the completing the square technique or algorithm. So x squared plus 8x, and then just a 33. Well, I guess, I never tried that before. I guess you got to write it in as y equals. With functions, you could sometimes get lazy and just skip the part where there's a left-hand side. But you write them each in as y equals and see where they cross. The x values for which, or where they cross, would be at negative 11 and 3. So that would be an indication that we have an answer. That is most likely correct. I mean, it's also possible I missed a step along the way, but we're mostly correct, at least, at a minimum. Here they're asking us to determine the value of x when f of x is equal to negative 22. So that's kind of like what we just did here on the previous one, using the intersection, except they're saying specifically we have to do it algebraically, so we don't have a choice there, right? But we can at least get the answer, so we know what we're getting going in. So they're telling us we have f of x is equal to, it's going to be a fraction with negative 3 x minus 5 up top and a 2 on the bottom. And then they're saying f of x, I want to never do that. I was just going to try that and see. Yeah, it would have been nice if it just automatically put an f of x in it for you. But I could see why it wouldn't. I'm going to go to the home screen here. Get f of x is equal to that fractional expression, and f of x is equal to negative 22. We're looking for where they cross, which is at the x value of 13. So I know going in that x is equal to 13. But I need to do it algebraically, all right? So they tell us f of x is equal to negative 3x minus 5 over 2. They also tell us that f of x is equal to negative 22. So if these two things are equal, both equal to f of x, they're going to be equal to each other. So this is going to be equal to this. So negative 3x minus 5 over 2 equals negative 22. I'm going to multiply both sides by 2 because I want to get rid of that fraction. Wipes out the 2 over here, so I'm left with negative 3x minus 5. And on the right-hand side, negative 44. I'm going to add 5. It's going to get me to a negative 39. Divide out the negative 3. and I get x equals 13. Right? So it's nice to know going in what I'm trying to get as a final answer. Right? So and that ended up being the case, so that's good news. All right. Let's go on to number 30. Rationalize the denominator. So when you rationalize the denominator, you take the part of the denominator that's radical. And sometimes there's another coefficient there or something. Multiply top and bottom by that radical. You get, and then multiply across. 4 times radical 2 is 4 radical 2. Radical 2 times radical 2 is just 2. All right. If you're not sure about that, Desmos will help you. All right, you do it that way. Something to bear in mind, if you take radical 2 and multiply it by radical 2, you're really getting radical 4. Radical 4 happens to be equal to 2. Then we can simplify. 2 goes into 4 twice. So my final answer here would be 2 radical 2. They did say simplest form, so we have to make sure that we do that. There will be some problems where it seems like they give you way too much space to do it. Don't read anything into that because they give you the same amount of space to do everything in the part 2, 3, 4. So just kind of going back, you see everything got its own page. I think they don't want people just assuming that a question is going to be really lengthy or really short based off the amount of space that they have. Because, I mean, if they told me that all I had was that amount of room to do it, I'd be like, okay, this is going to be a quick one. I think they're trying to kind of stay away from that. I don't know why. That just seems to be the way of it.